Hello dear learner and welcome to this session on vector calculus. In this lecture, I Dr. Purnima Tiwari, Associate Professor of Mathematics, the Bhopal School of Social Sciences will explain the concept of curl of a vector function. Curl measure rotation or tendency of a vector field around a point. To understand this concept, you must be familiar with vector algebra, that is addition of two vectors, their subtraction, multiplication with a scalar quantity, scalar product and vector product. And you also must be able to calculate partial derivatives of a function. You must aware with vector field with the standard notation vector f is equal to f1 I cap plus f2 j cap plus f3 k cap. And the operator del, this is the Nabla operator and it is equivalent to I cap del by del x plus j cap del by del y plus k cap del by del z. When we apply this del operator along with the dot product to a scalar function, we get the concept of gradient, and when we apply this operator along with the scalar product on a vector function, we get divergence. So, to understand this concept, you must view my previous videos on scalar product, vector product or gradient and divergence. Let us start with the definition of curl. A vector f of three variables x, y and z, if it is a continuously differentiable vector function, then its curl is denoted by curl f and it is defined by Nabla cross f. You must recall value of Nabla operator, which is I cap del by del x plus j cap del by del y plus k cap del by del z, and f is a vector function. We can calculate curl of this vector mathematically by solving the determinant where the first row includes unit normal vectors I cap, j cap, k cap. Second row are the components of this Nabla operator del by del x, del by del y and del by del z, and third row is component of this vector f, f1, f2, f3, as this vector f is f1 I cap plus f2 j cap plus f3 k cap. On solving this determinant, we can calculate curl of this vector function. Next, we will calculate curl of a constant vector and that value is 0. Now, suppose a constant vector f is given to us. So, when we write it in standard notation, that is f1 I cap plus f2 j cap plus f3 k cap. Its components f1, f2 and f3 are constants. That means, when we find their partial derivative with respect to x, y or z, those partial derivatives are 0. So, when we have to calculate this curl, first we will write the formula in terms of determinant with the first row unit normal vectors I cap, j cap, k cap, second row partial derivatives with respect to x, y and z, and third row are the components of the given vector. Now, when we expand this determinant, we find that this curl f is equal to I cap del by del y of f3 minus del by del z of f2. You must know how we expand the determinant. Minus of j cap del by del x of f3 minus del by del z of F1 plus k cap del by del x of F2 minus del by del y of F1. Now, as those partial derivatives of F1, F2, F3 are 0, so all these values del y by del F3 equal to 0, del F2 by del z is also equal to 0, and likewise the other partial derivative of F3 with respect to x, F1 with respect to z, F2 with respect to x and F1 with respect to y. All these values are 0. So, it means curl of this vector is 0 I cap plus 0 j cap plus 0 k cap, which is equivalent to 0 vector. Thus, we get curl of a constant vector is 0. Next, we will find curl of position vector of any point vector r, and you know that position vector is given by x I cap plus y j cap plus z k cap. When we compare it with the standard form of vector f, f1 I cap plus f2 j cap plus f3 k cap, we can find the value of f1 is x, f2 is y and f3 is z. To calculate, we apply the formula for curl in the form of determinant, including first row for unit normal vectors I cap, j cap, k cap, second row for partial derivative and third row for the components of the vector. Now, when we substitute these values, value of the determinant is I cap, j cap, k cap, del by del x, del by del y, del by del z, and the third row is x, y and z. Now, we can expand this determinant and we will get the value of curl of vector r. For the expansion, we get I cap of del by del y z minus del by del z of y minus of j cap del by del x of z minus del by del z of x plus k cap del by del x of y minus del by del y of x. Now, as per rule of partial derivative, you know that the partial derivative of z with respect to y is 0. Likewise, partial derivative of y with respect to 0 and partial derivative of z with respect to x, partial derivative of x with respect to z, partial derivative of y with respect to x and partial derivative of x with respect to y, all are 0. That means, this value is 0 I cap plus 0 j cap plus 0 k cap, which is a 0 vector. Hence, we find that curl of a vector r, position vector r is always a 0 vector. Next, we will find curl of vector f, where vector f is x y square I cap plus 2 x square y z cap minus 3 y z square k cap at the points 1, minus 1 and 1. When we compare it with the standard notation, we get value of f1 is x y square, value of f2 is 2 x square y z and value of f3 is minus 3 y z square. We substitute this value in the formula of curl of vector f, which is I cap, j cap, k cap, del by del x, del by del y, del by del z, F1, F2, F3. On substituting values of F1, F2, F3, we get curl of this vector F is the determinant of I cap, J cap, K cap, del x, del y, del z, x y square, 2x square y z and minus of 3y z square. Now, we have to expand this determinant. So, this value is I cap del by del y of minus of 3y z square minus del by del z of 2x square y z minus of j cap del by del x of minus 3y z square minus del by del z of x y square plus k cap del by del x of 2x square y z minus del by del y of x y square. Now, we have to do partial differentiation. When we differentiate minus 3y z square partially with respect to y, so that value is minus 3z square. As minus 3z square deals like a constant and we just differentiate y with respect to y, that value is 1. Now, minus when we differentiate this term 2x square y z with respect to z. So, this term 2x square y will deal like a constant and we will just differentiate z with respect to z. So, we will get 2x square y minus of j cap. Likewise, when we differentiate 3y z square with respect to x, this whole term deal like a constant. Therefore, value of this partial derivative is equal to 0. Similarly, when we differentiate xy square with respect to z, so this term is a constant with respect to z and this value of this partial derivative is also 0. So, here we will get 0 into j cap. Now, plus k cap. When we differentiate 2x square y z partially with respect to x, we just need to differentiate x square as 2y z deal like a constant. Differentiation of x square is 2x minus. Again, when we differentiate xy square partially with respect to y, we get minus of 2xy. On solving this, we will get minus 3z square minus 2x square y of I cap, 0 j cap is 0 plus 4xyz minus 2xy k cap. Now, this is the value of curl of this vector f. But we have to find value of curl f at the given point 1, minus 1 and 1. That means, in this value we have to substitute x equal to 1, y equal to minus 1 and z equal to 1. On substituting these values, we will get the desired quantity. So, here curl of this vector f at the point 1, minus 1, 1 is minus 3 z square, that means 1 square, minus 2 1 square multiplied with minus 1 of I cap plus 4 times of 1 minus 1 into 1 minus 2 times of 1 into minus 1 of k cap. So, this value is minus 3 and plus 2. that is minus of 1 into I cap. So, here we can directly write I cap minus of I cap, and again this is minus 4 and plus 2, that means minus of 2 k cap. That means if the function f is x y square I cap 2x square y z j cap and minus 3 y z square k cap, the value of curl at the point 1 minus 1 and 1 is given by minus of I cap minus 2 k cap. For better understanding of this topic, you may solve some more examples to determine curl of a vector function.